Hello and welcome to this short video which provides an overview of the isolated inverter platform from Analog Devices. The isolated inverter platform is a rapid development system for hardware and software development in three-phase motor control. Flexible evaluation of ADI isolation technology in a highly configurable system-oriented platform is enabled through multiple test points and connectivity options. The benefits of ADI isolated sigma-delta converters for voltage and current measurement, isolated gate drivers and power controllers can be explored in a full system application at DC bus levels up to 800 volts. There are two models available, the isolated inverter platform with basic gate drivers and the corresponding platform with full-featured IGBT gate drivers. An easy plug connector allows controller connection to an ADSP CM408 processor evaluation board or to an FPGA control board known as FMC Modcon. In addition, all of the control and feedback signals are brought out to 0.1-inch headers to enable alternative connectivity to other processor or FPGA platforms. The board is designed to work from a DC supply in the range 24 volts to 800 volts DC and is rated up to 2 kVA without forced air cooling, although additional power throughput can be achieved with fan cooling added. A series connected diode implements a half-wave rectifier at the input, so if needed, the power board can be driven from an AC supply. However, output power is limited in this case. If a full AC front end is required, the inverter platform can be utilized in conjunction with the ADP 1047 evaluation board up to 300 watts or the ADP 1048 evaluation board up to 600 watts. An isolated I2C interface is provided on the inverter platform so that the ADP 1047-48 evaluation board can be easily controlled by the same processor or FPGA interface. The block diagram in this slide outlines the inverter board design for the platform with full-featured gate drivers. In this instance, the controller is the ADSP CM408 mixed-signal processor, with control inputs coming from either manual switches and dials or from a Windows-based graphical user interface on a connected laptop. PWM control signals are applied to the inverter IGBTs by means of isolated gate drivers, in this case the ADUM4135. Each motor phase current is measured from the voltage drop across precision shunt resistors, which is applied to isolated sigma-delta modulators, the AD7403. Scale DC bus voltage and motor phase-to-phase voltage measurements options are also available using the AD7403. The isolated bit streams from the modulators are routed to the built-in sync filters on the ADSP CM408 processor, where they are filtered and decimated. Overcurrent protection is implemented at the DC bus current using comparators and signal isolators, while short-circuit protection is provided by the desaturation detection capability of the IGBT gate drivers. Bias supplies for the high-side gate drivers and sigma-delta modulators are derived from a multi-output flyback converter that uses the ADP 1621 controller. This clip shows the platform being used in a typical lab setup. In this case, the platform is supplied from the rectified 230 volt AC mains with a voltage doubler output, and so is running from approximately 600 volts DC bus. A 2-pole induction motor is being driven under open loop volts per hertz control at a low speed. The scope shows one of the motor phase currents. Motor phase current shunt measurements are transferred to the control processor via the isolated sigma-delta modulators and are conditioned by the hardware sync filters within the ADSP CM408 mixed-signal processor. For visualization, the decimated samples are streamed to a graphical user interface, where they are shown here. Motor phase and DC bus voltage measurements can equally be captured, and these are shown in this plot. These can be useful for implementing some sensorless control algorithms and for other functions such as loss of phase protection or spinning machine synchronization.